Disaster Management, Seismicism and Tsunamis. Chapter 4. Seismicism, literally, seism means an earthquake, refers to or of relating to an earthquake or earthquakes. And ism means any distinctive but unspecified doctrine or theory. Thus, seismicism in general terms refers to earthquake phenomena. However, earth scientists define seismicism as the study of the worldwide distribution of earthquakes over time and the probability of an equation occurring in a specific location. Seismic zones. Technically, a seismic zone is a region in which the rate of the seismic activity remains fairly constant, whether it is incredibly rare or extremely common. However, in practice, it is frequently used to denote an area with an increased risk of seismic activity. The most high activity seismic zones are located along the fault zones, regions of Earth's crust which are prone to seismic activity. Fault zones often occur when the tectonic plates diverge or converge or slide past each other, but they can also be found around volcanoes originating from hotspots. Many nations have government agencies concerned with seismic activity. These agencies use the data that they collect about seismic activity to divide the nation into various seismic zones. A number of different zoning systems are used, from numerical zones to colored zones, with each number or color representing a different level of seismic activity. An earthquake is the one of the most destructive natural hazard. It is a sudden shaking of Earth's crust. The earthquakes can occur at any time of the year, day or night with sudden impact. They can destroy buildings and infrastructure in seconds, killing or injuries in the inhabitants. The stresses caused by the plates of the Earth's crust due to the thermal convection currents results in the movement along the plate boundaries in the form of pulling away from each other, pushing against one another, and sliding sideways related to each other. All these movements are associated with earthquakes. The earthquake magnitude or amount of energy released is determined by the use of seismograph. In India, from 1950 to 2005, about 12 significant earthquakes occurred whose magnitude ranged from 6.0 to 8.5. These earthquakes occurred in 1950, 1956, 1967, 75, 88, 91, 1993, 97, 1999, 2001 and 5. Technically, an earthquake is a sudden vibration that travels through the earth crust. It is estimated that each year there are as many as 1.3 million quakes with a magnitude greater than 2.0, the threshold of which humans can feel the vibrations. Majority of them are so small that we do not even notice them. The earthquakes that capture our attention are the rare big ones that have caused a great deal of property damage and claimed many lives. Over the last decade alone, earthquakes and tsunamis, avalanches and landslides caused have killed 688,000 people around the world. Perhaps the most lethal quake in history has been the magnitude of 8.0 and struck China's Shanxi province in 1556, claiming as many as 830,000 lives. The worst was in 2010, which struck offshore of Japan, measuring an 8.7 magnitude. Origin and occurrence. Earthquakes can be caused for a variety of reasons, including meteor impacts and volcanic eruptions, and even sometimes man-made events like man collapses under underground nuclear test, but most naturally occurring earthquakes are caused by the movements of pieces of Earth's surface, which are called as tectonic plates. Causes of earthquakes. The earliest documented earthquake occurred in China in 1177 BC, although they had some wild assumptions. For most of the history, people didn't really have any concrete idea As to what really caused earthquakes, it wasn't until the 1800s that scientists began to study and measure earthquake activity in the earth. Using a device developed in Italy called seismograph, finally in the mid 1960s, researchers in the United States and Great Britain came up with a theory that explained why the earth shook. The theory, called plate tectonics, is that the earth crust or lithosphere comprises many plates that slide over a lubricating layer called asthenosphere. All the boundaries between these huge plates of rocks and soils, the plates sometimes move apart and the magma or molten rock comes to the surface, where it is called lava. It cools and forms new parts of the crust. The line where this happens is called a diverging plate boundary. The plates also push against each other. Sometimes one of the plates will sink underneath the other into the hot layer of magma beneath it and partially melts. Other times, the edges of the two plates will push each other and rise upward, forming mountains. This area is called a convergent plate boundary. But in other instances, plates will slide by and brush against each other, but very slowly. At the region between the two plates called transform boundary, energy builds in the rock. A fault line, a break in the earth's crust where blocks of the crust are moving in different directions will form. Most, though not at all, earthquakes happen along the transform boundary fault lines. With these faults, rocks push together tightly, creating friction. If there is enough friction, the rock will give way steadily. The sudden, intense shift along the already formed faults are the main sources of earthquakes. Most earthquakes occur around the plate boundaries because this is where strain from the plate movements is felt most intensely, creating fault zones, groups of interconnected faults. In a fault zone, the release of kinetic energy at one fault may increase the potential energy in a nearby fault, leading to other earthquakes. That is why several earthquakes occur in an area in a short period of time. These additional quakes are called as foreshocks or aftershocks. The quake with the large magnitude is called as main shock. Any quakes that occur before the main shock are called foreshocks, and those that occur after the main shock are called the aftershocks. Most of the time, the worst aftershocks occur within the first 24 hours after the main shock hits. Bigger earthquakes trigger more aftershocks with larger magnitude. Seismic waves. When a pebble is tossed into a pond, it creates radiating waves in the water. An earthquake does the same thing with energy. When the plates fracture or slip, energy is released as seismic waves. Types of seismic waves. There are several different types of seismic waves that move in different ways. That move in different ways. The two main types of seismic waves are body waves and surface waves. Body waves can travel to the Earth's inner layer, but surface waves can only move along the surface of the planet like ripples on water. Earthquakes radiate seismic energy as both body and surface waves. Body waves. Traveling through the interior of the earth, body waves arrive before the surface waves do at the recording station. These waves are of a higher frequency than the surface waves. B waves, S waves, P waves. The first kind of body wave is a P wave or primary wave. This is the fastest kind of seismic wave and consequently the first to arrive at the seismic station. It can move through solid rock as well as the liquid layers of the earth. It pushes and pulls the rock as it moves through. P waves are also known as compressional waves because of the pushing and pulling that they do. Subjected to a P wave, particles move in the same direction that the wave is moving in, called the direction of wave propagation. S waves. The second type of body wave is called the S wave or secondary wave, which is the second wave that is felt in an earthquake. And S wave is slower than distribution of earthquakes. Earthquakes tend to occur on either side of the Pacific Ocean, including the western coast of North and South America, as well as East Asian islands like Japan. This is because the crystal plates of these continents are moving and sliding over the plates that make the Pacific Ocean floor. These areas constitute the Ring of Fire because they also contain many active volcanoes. Four out of every 5 earthquakes occur in the Ring of Fire. The series of faults trace through southern Europe and Central Asia. Some of the world's worst earthquakes and some of the most recent ones have occurred over faults that crisis crossed through Turkey and Iran. Management and mitigation. Anticipatory hazard management deals with the risk assessment and deliberate adjustment to minimize the impact of the natural hazards, while mitigation refers to efforts that to prepare for the disaster and to reduce its damage. Hazard management and mitigation also involves several governmental and non-governmental agencies, voluntary organizations and insurance companies performing several tasks in a phased manner. It calls for proper planning and execution of those plans prior to, during and after the incidence of a disaster. Before the incidents, hazard warnings are released through radio, television, other mass communication systems. People are evacuated from the hazardous areas and moved to safer locations such as established emergency shelters which provide the evacuees with food, shelter and protection. The roads are cleared for the movement of emergency vehicles. It involves two phases, prediction and preparation. Prediction of earthquakes. Today, scientists understand the earthquakes a lot better than they did a few decades ago. However, most of the earthquake predictions are still vague and are best. They have had more success in predicting the aftershocks, additional shocks following an initial earthquake. They can make a good guess of how an earthquake originating along one fault will cause additional earthquakes in connected faults. Another area of the study is the relationship between the magnetic and electrical changes in the rock material and earthquakes. Some scientists have hypothesized that these electromagnetic fields change in a certain way just before an earthquake. Seismologists are also studying gas seepage and tilting of the ground as warning signs of earthquake. In 2009, for example, a technician at the Italy's National Institute of Physics claimed that he was able to predict a L'Aquila earthquake by measuring the radon gas seeping from the Earth's crust. Despite persistent efforts being put in by scientists across the world, they have not yet achieved total success in establishing a scientific method of predicting earthquakes. Hence, preparation still remains the best means of defense. B. Preparation. Disaster preparedness includes all the activities that are carried out prior to the advance notice of a catastrophe in order to facilitate the use of available resources, relief and rehabilitation in the best possible manner. Over the 50 years, many advances have been made in earthquake preparedness, particularly in the field of construction engineering. In 1973, the Uniform Building Code, an international set of standards for building construction, added specifications to fortify buildings against the force of seismic waves. This includes strengthening support material as well as designing buildings so that they are flexible enough to absorb vibration without falling or deteriorating. Architects and engineers also trying to develop innovations that would provide an even greater protection against earthquakes. For example, 2 US scientists have designed a structure that instead of toppling deliberately collapses upon itself and then reforms after the quake subsides. Another component of earthquake preparedness is educating the public about the processes involved in an earthquake and giving instructions how to prepare one's house for the possible earthquake as well as one who is supposed to do when a quake hits. They are One must make sure that the house doesn't move from its foundation during the movement of the ground resulting from an earthquake. For this purpose, the ground is to be fortified with concrete. Prior to relieving the house for the safer destinations like disaster shelters, one must shut off power, water, and gas supplies to the house. Water, food, medicines should be stored to meet an emergency sufficient at least for a few days. A first aid kit, a flashlight, a battery operated portable radio may be kept handy in case of they become necessary. During an earthquake, emergency communication centers, emergency medical services, fire and rescue services, law enforcement agencies, hospitals, local and state offices, and agencies of emergency management and pressed into service and kept on high alert so that they can operate round the clock. The disaster management agencies provide personal technical expertise, equipment, and other resources on footing. The primary task of the agencies is to locate and rescue the victims and move them to the emergency shelters and provide them with food and emergency medical services at the individual. During an earthquake, if indoors, one should, if possible, get under a table or other solid piece of furniture and hold on until the shaking ceases. If indoors, one should stay against an inside wall and not to go near windows or outside until the shaking stops. Use of elevators should be avoided. If one is driving, it is better to drive slowly until reaching a shelter, but should not stop or under overpasses, bridges, large trees, power lines, or other potentially unstable areas. If one is outside during the earthquake, it is best not to move much. Avoid buildings, objects, or structures that could fall. The management and mitigation after an earthquake involves two phases: restoration and reconstruction. Restoration involves a restoration of major services such as supply of fuel, electricity, water, and communication. Return of the refugees to their original destinations. Reconstruction involves rebuilding of the houses and other structures affected by the earthquake, such as roads, canal, bunds, railway tracks, and supply of the communication facilities such as power, telephone lines, water, milk and gas pipes, electronic signal repeater towers, etc. At the individual level, several smaller tremors can occur after the initial earthquake. These aftershocks can cause additional damage or lead unstable structures to collapse. Hence, it is good to avoid partially damaged structures until the integrity is certified by an expert. After an earthquake, it is essential to be wary of a natural gas leak. One must refrain from the lighting matchsticks or using lighters which could cause gas in the air to explode. In such a case, the gas valve should be turned off, the windows should be opened, and one must leave the house or buildings as quickly as possible. One must also look around for water leaks or spilled liquids that may be inflammable or toxic. Those trapped in a building or under rubble should not move much or light matchsticks. They must tap on something that generates sound to signal rescuers rather than shouting. If one shouts, one could potentially inhale deadly or debilitating dust. If one shouts, one could potentially inhale deadly or debilitating dust. Similarly, one must cover one's mouth to protect the lungs against dust and other airborne particles. In the after tremors of an earthquake, it is important to receive updates from the local authorities, whether over the radio or television if possible, and it is very essential to follow the advice given by them. At present, we can only hope that in times to come, improvements in prediction and preparedness should further minimize the loss of life and property associated with earthquakes. Like any other natural disaster, earthquakes are an unavoidable force generated by the mighty natural processes that shape our planet. And what we can do is to increase our understanding of the phenomena and develop better ways to deal with the problem. These are the 5 deadliest earthquakes in the recent times, and the date of the earthquake, place, magnitude, and death toll. This is all about the earthquakes, types of earthquakes, origin of earthquakes, and seismic waves, how it is caused, and how we can prevent this or reduce this, how we can prevent these earthquakes. This is from the Natural Disaster Management Telugu Academy book.